Hello, in this lecture we will find the area of the green shape in three different ways. In the drawing we have a circle. We know that the radius of this circle equals to 5 units, and we also know that angle ACB, this angle, equals to 60 degrees, and we know that tangent CA is tangent to this circle at point A, and tangent CB is tangent to the circle at point B. And we want to find out the area of the green shape. Okay. First of all, we will define the center of this circle as point O, and we will join together points A and O by a straight line. Actually, AO is the radius of this circle that equals to 5 units, because it starts, line segment AO starts from the center of the circle, that is to say from point O, and ends at point A, that is a point on the circle itself. For that reason, AO is the radius of this circle. We will join together points O and B by a straight line. And OB is also the radius of this circle for the same reason. And we have a rule number 1, that states that a tangent to a circle is perpendicular to the radius drawn to its tangency. Again, rule number 1 states that a tangent to a circle is perpendicular to the radius drawn to its tangency. So actually, if we have this radius and we have here tangent BX is tangent to this circle at point X, and we have the radius that is drawn to the point of tangency, that is to say to point X, then the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees. So whenever you have a tangent and a radius that is drawn to the tangent, to the point of tangency, that is to say to point x, then the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees. Okay, so actually here we have tangent CB, that is tangent to this circle at point B. Actually point B is the point of tangency, and the radius is drawn to the point of tangency. Actually this radius touches the point of tangency, that is to say point B. Therefore the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees. And the same thing also is true for in the other side. We have tangent CA, that is tangent to this circle at point A, and we have this radius that is drawn to the point of tangency, that is to say it is drawn to point A. Therefore the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees. Okay, and we also have another rule, rule number 2, that is also called two tangents theorem. Rule number 2, or two tangents theorem, states that the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 2, that is also called two tangent theorem again. Two tangent theorem states that the lengths of two tangents from a common external point to a circle are equal. So actually, if we have external point, that is to say point D is an external point because it is not in the circle and not on the circle itself, but it is outside the circle. Therefore point D is a common external point, and if from point D we draw two tangents to this circle, the first tangent is tangent DB. Tangent DB is tangent to this circle at point B, and we have also tangent DA, that is tangent to this circle at point A. Then the lengths of those two tangents will be equal to each other, that is to say DB will be equal to DA. Okay, so whenever you draw two tangents to a circle from a common external point, then the lengths of those two tangents will be equal to each other. In this case, DA will be equal to DA will be equal to DB. Okay, so in our drawing we have common external point, that is to say point C, and from point C we have two tangents to this circle, tangent CA and tangent CB. Therefore, according to two tangents theorem or rule number 2, the lengths of those two tangents will be equal to each other, that is to say CA will be equal to CB. CA will be equal to CB. So those two sides will be equal to each other. Okay? So in the next step we will join together point C and O by a straight line. And we will prove that triangle ACO congruent to triangle CBO. Okay, so we will focus on triangles CAO and triangle CBO. So on those two triangles, we know that OB equals to OA. Both of those two sides are the radiuses of this circle that equals to 5 units. Okay, so OB equals to OA equals to the radius of the circle that equals to 5 units. And we also know that CA equals to CB, CA equals to CB according to two tangents theorem. CA equals to CB according to two tangents theorem. And also CO is a common side. It belongs to both triangles. So CO equals to CO. It is a common side. It belongs both to triangle AOC, and CO also belongs to triangle COB. Okay? So we actually proved that all the sides of triangle CBO are equal to all the sides of triangle COA. Therefore, those two triangles can go into each other according to side rule. So triangle COA is congruent to triangle COB according to side rule. Okay, triangle COA congruent to triangle COB according to side rule. Okay, so from the fact that those two triangles congruent to each other, we can conclude that angle OCB, this angle OCB equals to angle OCA. And they are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles are congruent to each other, therefore the corresponding angles will be equal to each other. So if we define angle OCA as x, then angle OCB will be also equal to x because they are equal to each other. Okay, angle OCB will be also equal to x. So actually we know that x plus x equals to 60 degrees according to what is given us in the question. So 2x equals to 60 degrees. So here, if we divide this equality by 2, we will get that x equals to 30 degrees. Angle x equals to 30 degrees. So here we can write that x equals to 30 degrees. And also here x equals to 30 degrees. So in the next step we will focus on this triangle, the right triangle, triangle AOC. So in the right triangle, triangle AOC, we know that tangent 30 degrees equals to OA over AC. Again, in the right triangle OSC, we know that tangent 30 degrees equals to OA over OC. But what is the value of OA? OA equals to 5 units, according to what is given us in the question. And tangent 30 degrees equals to 1 over root 3. So in total, we got that tangent 30 degrees equals to 1 over root 3. So 1 over root 3 equals to 5 over OC, 5 over AC. Actually, tangent 30 degrees equals to OA over AC. Therefore, tangent 30 degrees equals to 5 over AC. So here we will multiply this equality by AC, and we will get that AC over root 3 equals to 5. So here we will multiply this equality by root 3, and we will get that AC equals to 5 times root 3. Okay, AC equals to 5 times root 3. So we can write here that AC equals to 5 times root 3. And because of the fact that AC equals to BC, BC will be also equal to 5 times root 3 units. And what is the area of triangle AOC? The area of triangle AOC that is actually the way you write the area of triangle AOC. This means the area of triangle AOC. So the area of triangle AOC will be equal to the base of the triangle times the height to the base over 2. Again, the area of triangle AOC equals to the base of the triangle times the height to the base over 2. So what is the base of triangle AOC? The base is actually OA and the height is AC over 2. So the area of triangle AOC equals to the base that is OA times the height that is AC over 2. But what is the value of OA? OA equals to 5 units times AC. AC equals to 5 times root 3 units, all divided by 2. So the area of triangle AOC equals to 5 times 5 times root 3 over 2 square units. 5 times 5 is 25, so the area of triangle AOC will be equal to 25 times root 3 over 2 square units. Okay, the area of triangle AOC equals to 25 times root 3 over 2 square units. But because of the fact that triangle AOC can go into triangle BOC, they have also the same areas. So the area of triangle AOC equals to the area of triangle BOC. Again, the area of triangle AOC equals to the area of triangle BOC because they can go into each other. And what is the area of quadrilateral ABCO? The area of quadrilateral ABCO equal to the area of triangle AOC plus the area of triangle BOC, because it consists those two triangles, so the area will be equal to the sum of the areas of those two triangles. So it equals to the area of triangle AOC plus the area of triangle BOC. Again, the area of quadrilateral ABCO equals to the area of triangle AOC plus the area of triangle BOC. But we know that the area of triangle AOC equals to the area of triangle BOC. So we can substitute the area of triangle BOC by the area of triangle AOC because they are equal to each other. So we will get that the area of quadrilateral ABCO equals to the area of triangle AOC plus the area of triangle AOC equals to 2 times the area of triangle AOC. Okay? But we have already found out that the area of triangle AOC equals to 25 times root 3 over 2 square units. So the area of quadrilateral ABCO will be equal to 2 times the area of triangle AOC, that is to say 2 times 25 times root 3 over 2. So here we have 2 over 2 is 1, so 2 will get cancelled, and we will get that the area of quadrilateral ABCO equals to 25 times root 3 square units. Okay? The area of quadrilateral ABCO equals to 25 times root 3 square units. But what is the area of the green shape? The area of the green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. Again, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. So I will write it down. The area of the green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. Again, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. Okay? So we have new rule number 3. Rule number 3 states that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, the sum of the angles in any quadrilateral the sum of the angles in any quadrilateral is equal to 360 degrees. I will read rule number 3 again. Rule number 3 states that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABCO will be equal to 360 degrees. That is to say 60 degrees plus 90 degrees plus 90 degrees plus the size of angle AOB, the size of this angle, must be equal to 360 degrees according to rule number 3. Okay. Again, according to rule number 3, the sum of the angles in quadrilateral ABCO equals to 360 degrees. Here we have 60 degrees plus 90 degrees plus 90 degrees is 240 degrees. So I write it down. (240 degrees plus the size of angle A or B must be equal to 360 degrees. Here we will subtract from this equality 240 degrees and we will get that the size of angle A or B is equal to 360 degrees minus 240 degrees is 120 degrees. So we found out that the size of this angle A or B, equals to 120 degrees. Okay. So now we will return to our formula for the area of the green shape. Again, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector A or B. Okay. The area of the green shape equals to the area of quadrilateral ABCO minus the area of sector A or B. The area of sector A or B. So what is the area of sector A or B? The area of sector A or B equals to the area of this shape, sector A or B, equals to pi r squared times 120 degrees over 360 degrees. Okay, the area of sector A or B equals to pi r squared times 120 degrees over 360 degrees. R equals to 5, so pi r squared is 25 pi. And 120 degrees over 360 degrees is 1 over 3, so in total we got that the area of sector A or B equals to 25 pi over 3 square units. And we have already found out that the area of quadrilateral ABCO equals to 25 times root 3 square units. So the area of the green shape, according to this formula, will be equal to the area of quadrilateral ABCO, that is 25 times root 3 square units, minus the area of sector A or B, that is 25 pi over 3 square units. So the final answer to the question is that the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so we finished with the first method, and in the next step we will find out the area of the green shape according to the second method. We will define the center of this circle as point O. We will join together points A and O by a straight line. OA is the radius of the circle that equals to 5 units. This angle equals to 90 degrees. I explained those things, these things in method number 1. We will join together points O and B by a straight line. OB is also the radius of this circle that equals to 5 units, and this is a right angle. We will join together points C and O by a straight line. And we have already found out in method number 1 that this angle equals to 30 degrees, and this angle also equals to 30 degrees, and AC equals to 5 times root 3. AC equals to BC according to two tangents theorem. Therefore, BC will be also equal to 5 times root 3 units. We will extend side CO until it touches the circle at point H. Then we will draw a tangent to this circle at point H. OH is the radius of this circle that equals to 5 units because of the fact that line segment OH starts from the center of the circle, that is to say from point O, and ends at point H, that is a point on the circle itself. Therefore OH is the radius of the circle. So we have the radius that is drawn to the point of tangency, that is to say to point H. For that reason, here we have 90 degrees. The radius is perpendicular to the tangent, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will extend CA until it touches the circle O. We will extend CA until it intersects with the tangent, and we will define the intersection point between CA and the tangent as point P. Point P is the intersection point between CA and the tangent H. Then we will also extend CB until it intersects with the tangent and we we will define the intersection point between CB and the tangent as point Q. Then we will focus on the right triangle CPH. CPH is the right triangle because this angle equals to 90 degrees. So on the right triangle CPH, we know that the sum of the angles in this right triangle CPH equals to 180 degrees. That is to say 30 degrees plus 90 degrees plus the size of angle CPQ must be equal to 180 degrees. Okay, the sum of the angles in the right triangle CPH equals to 180 degrees. Here 30 degrees plus 90 degrees is 120 degrees, so I will write it down. 120 degrees plus angle CPQ equals to 180 degrees. Here we will subtract from this equality 120 degrees and we will get that the size of angle CPQ equals to 180 degrees minus 120 degrees is 60 degrees. So we found out that angle CPQ, this angle, equals to 60 degrees. We will repeat on the same process on the right triangle CHQ. So on the right triangle CHQ, (30 degrees plus 90 degrees). The sum of the angles in the right triangle CHQ equals to 180 degrees, that is to say 30 degrees plus 90 degrees plus the size of angle CQH must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay? The sum of the angles in triangle CHQ equals to 180 degrees. Here 30 degrees plus 90 degrees is 120 degrees, so I will write it down. 120 degrees plus the size of angle CQH must be equal to 180 degrees. Here we will subtract from this equality 120 degrees and we will get that the size of angle CQH equals to 180 degrees minus 120 degrees equals to 60 degrees. So we found out that angle CQP equals to 60 degrees. So in the big triangle CPQ, we have three angles that are equal to 60 degrees. Therefore, we can conclude that triangle CPQ is an equilateral triangle. Equilateral triangle. Okay, triangle CPQ is an equilateral triangle because it has three angles that are equal to 60 degrees. Okay, and we have new rule, rule number 4. Rule number 4 states that the center of a circle inscribed in a triangle is the incenter of the triangle. So I will read rule number 4 again. Rule number 4 states that the center of a circle inscribed in a triangle is the incenter of the triangle. Again, the center of a circle inscribed in a triangle is the incenter of the triangle. Okay, so the meaning of rule number 4 is that the center of a circle, in our example, the center of the circle is at point O, and the meaning of rule number 4 is that the center of the circle that is point O is also the center of the triangle that contains the circle. That is to say, point O is also the center of triangle CPQ. So we can conclude from rule number 4 that point O is the center of triangle CPQ, of equilateral triangle, triangle CPQ. Again, point O is the center of equilateral triangle, triangle CPQ. Okay? And we have also rule number 5. Rule number 5 states that the height from the center of an equilateral triangle the height from the center of an equilateral triangle crosses the side. I will read rule number 5 again. Rule number 5 states that the height from the center of an equilateral triangle crosses the side. So what is the meaning of rule number 5? The meaning of rule number 5 is that if you draw height from the center of an equilateral triangle, then that height will divide the side to 2 equal parts. We know that triangle CPQ is an equilateral triangle, and we also know that point O is the center of equilateral triangle, triangle CPQ. So according to rule number 5, if from point O you will draw height to the side of triangle CPQ, then that height will divide the side to two equal parts. So here we have, for example, OH is the height from the center of this equilateral triangle. So according to rule number 5, OH divides the side CP to two equal parts. That is to say, according to rule number 5, CA equals to AP, because the height divides the sides to two equal parts. Therefore, CA will be equal to AP. CA equals to AP according to rule number 5. Okay, CA equals to AP according to rule number 5. But we know that CA equals to 5 times root 3. It is, we found out that CA equals to 5 times root 3. So from this equality we can derive that AP also equals to 5 times root 3. AP also equals to 5 times root 3. So we can write here that AP equals to 5 times root 3. And we can do the same thing on the other side of triangle CPQ. We know that OB is the height to the side CQ. So according to rule number 5, the height OB divides CQ to two equal parts. That is to say, CB equals to BQ. CB equals to BQ according to rule number 5. CB equals to BQ, but we know that CB equals to 5 times root 3 units. CB equals to 5 times root 3 units. So from this equality we can derive that BQ also equals to 5 times root 3 units. BQ equals to 5 times root 3 units. So we can write here that BQ also equals to 5 times root 3 units. And we also know that all the sides of equilateral triangle are equal to each other. So triangle CPQ is an equilateral triangle, therefore all of its sides are equal to each other. And what is the size of one side of equilateral triangle, triangle CPQ? The size of one side of triangle CPQ equals to 5 times root 3 plus 5 times root 3 is 10 times root 3. So the side PQ will be also equal to 10 times root 3 units. And we know that according to rule number 5, the height OH divides the side PQ to two equal parts. That is to say, HQ equals to PH. HQ equals to PH, again according to rule number 5. According to rule number 5, HQ equals to PH. And if we define HQ as X, then HQ equals to PH, so PH will be also equal to X. So from one side, PQ equals to 10 times root 3. But from the other side, PQ also equals to X plus X. So we can write down that 10 times root 3 equals to 2x. 10 times root 3 equals to 2x. Here we will divide this equality by 2 and we will get that x equals to 5 times root 3 units. Okay, x equals to 5 times root 3 units. Okay, and what is the area of equilateral triangle CPQ? The area of any triangle, if we have triangle ABC, and we know that AB equals to A units, AC equals to B units, and we also know that the angle between AB and AC is theta. Then the area of this triangle ABC, will be equal to A times B times sine theta over 2. Okay, again, the area of this triangle equals to A times B times sine theta over 2. So we will use this formula. We will use this formula in order to find out the area of equilateral triangle CPQ. So the area of equilateral triangle CPQ will be equal to CP times CQ times sine 60 degrees over 2. According to the formula that I presented to you, the area of equilateral triangle CPQ will be equal to CP times CQ times sine 60 degrees over 2 square units. But what is the value of CP and CQ? CP equals to CQ equals to 10 times root 3 units. So the area of equilateral triangle CPQ will be equal to 10 times root 3 square sine 60 degrees is root 3 over 2, all divided by 2. So the area of equilateral triangle CPQ equals to 10 times root 3 square times root 3 over 2 times 2. Here 10 times root 3 square is 300 and 2 times 2 is 4. So I will write it down that the area of equilateral triangle CPQ equals to 300 times root 3 over 4. Here 300 over 4 is 75, so I will write it down. In total we got that the area of equilateral triangle CPQ equals to 75 times root 3 square units. Okay, again, the area of equilateral triangle CPQ equals to 75 times root 3 square units. Okay. What is the area of the circle? The area of the circle, the formula for the area of any circle is actually pi r square. Again, the formula for the area of any circle equals to pi r square. And we know that in our circle r equals to 5 units, so r square is 5 square, so the area of the circle equals to 25 pi. And we have already found out that the area of triangle CPQ equals to 75 times root 3 square units. Again, the area of triangle CPQ equals to 75 times root 3 square units, and the area of the circle equals to 25 pi square units. And the area of triangle CPQ minus the area of the circle will be equal to the area of the green shape plus the area of the blue shape plus the area of the yellow shape. Again, the area of the big triangle, triangle CPQ, minus the area of the circle equals to the area of the green shape plus the area of the blue shape plus the area of the yellow shape. Okay, so I will write it down. The area of the equilateral triangle, triangle CPQ minus the area of the circle equals to the area of the green shape plus the area of the blue shape plus the area of the yellow shape. Again, the area of triangle CPQ minus the area of the circle equals to the area of the green shape plus the area of the blue shape plus the area of the yellow shape. Okay, but as you can see from the drawing, those three shapes are identical to each other. They have the same sides, and the angle between those two sides are also the same. It equals to 60 degrees. So because of the fact that those three shapes are identical, they will have also the same areas. So if we define the area of the green shape as x, so the area of the green shape is x, again x is the area of the green shape, then the area of the circle minus the area of triangle CPQ minus the area of the circle will be equal to the area of the green shape, that is x, plus the area of the blue shape, that is also x, plus the area of the yellow shape, that is also x. So in total, the area of the triangle minus the area of the circle equals to x plus x plus x, that is to say to 3x. It equals to 3x. Okay, so I will write it again. The area of the triangle CPQ minus the area of the circle equals to 3x. Okay, the area of triangle CPQ minus the area of the circle equals to 3x. But we want to find out the area of the green shape only, that is x. So in order to get the area of the green shape that is x, we must divide this equality by 3 and we will get the area of the green shape that is x. So we will divide this equality by 3 and we will get the value of x, that is the area of the green shape. Okay, so the area of triangle CPQ minus the area of the circle over 3 equals to x, that is the area of the green shape. Okay, so what is the area of triangle CPQ? It equals to 75 times root 3 square units minus the area of the circle is 25 pi square units over 3 will be equal to x. Okay, so the area of the green shape that is equal to x according to our definition equals to this expression. 75 over 3 is 25. 25 times root 3 minus 25 pi over 3 equals to x, that is the area of the green shape. Okay, so the area of the green shape according to the second method is 25 times root 3 minus 25 pi over 3 square units, because this expression equals to x and x equals to the area of the green shape according to our definition. So the area of the green shape equals to this expression. So we finished to find out the area of the green shape according to the second method. In the next step we will find out the area of the green shape according to the third method. First of all, we will join together points A and B by a straight line. We will define the center of this circle as point O, and we will focus on triangle ABC. We have already found out that CB equals to AC according to two tangents theorem. CB equals to AC according to two tangents theorem, and we have rule number 6 that states that in front of equal sides in the triangle there are equal angles. Okay, rule number 6 states that in front of equal sides in the triangle there are equal angles. Again, rule number 6 states that in front of equal sides in the triangle there are equal angles. So we know that in triangle ABC that AC equals to CB. So in front of CB we have angle PAC, and in front of AC we have angle ABC. So according to rule number 6, those two angles are equal to each other, because in front of equal sides in the triangle there are equal angles. So those two angles are equal. The angles that are located in front of equal sides are also equal to each other. So those two angles are equal to each other. So if we define one angle as x, then the other angle will be also equal to x, because they are equal to each other. And we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore x plus x plus 60 degrees must be equal to 180 degrees. That is to say, 2x plus 60 degrees must be equal to 180 degrees. Here we will subtract from this equality 60 degrees, and we will get that 2x equals to 180 degrees minus 60 degrees is 120 degrees. Here we will divide this equality by 2, and we will get that x equals to 120 degrees over 2 is 60 degrees. So we found out that this angle equals to 60 degrees, and this angle also equals to 60 degrees. Therefore, triangle ABC is an equilateral triangle. Okay, triangle ABC is an equilateral triangle. Okay, triangle ABC is an equilateral triangle, and we have already found out that in the first method that AC equals to 5 times root 3 and AC equals to BC, so BC also equals to 5 times root 3. We will join together points A and O by a straight line. OA is the radius of the circle that equals to 5 units. We will join together points O and B by a straight line. OB is the radius of the circle that equals to 5 units. We also found out that this angle equals to 120 degrees. And what is the area of the green shape? the area of the green shape equals to the area of triangle ABC minus the area of circular segment AB. Again, the area of the green shape equals to the area of equilateral triangle ABC minus the area of circular segment AB, the area of this white shape. And what is the area of triangle ABC according to the formula that I presented to you? The area of equilateral triangle ABC will be equal to 5 times root 3 square times sine 60 degrees over 2 is root 3 over 2 over 2 is root 3 over 4. So the area of equilateral triangle ABC equals to this expression. That is to say, 5 times root 3 squared is 75. So the area of equilateral triangle ABC equals to 75 times root 3 over 4 square units. Okay, the area of triangle ABC equals to 75 times root 3 over 4 square units. And what is the area of circular segment AB, this shape? The area of circular segment AB will be equal to the area of sector AOB, the area of sector AOB minus the area of triangle AOB. Again, the area of this shape, the area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. And we have already found out that the area of sector AOB equals to pi r squared times 120 degrees over 360 degrees. Okay. What is the area of triangle AOB? The area of triangle AOB, according to the formula that I presented to you, equals to 5 times 5 times sine 120 degrees over 2. Okay, so the area of circular segment AB equals to this expression. R equals to 5, so pi r squared is 25 pi. 120 degrees over 360 degrees is 1 over 3, so the area of sector AOB equals to 25 pi over 3 square units, and the area of triangle AOB equals to 25 times sine 120 degrees is root 3 over 2. Root 3 over 2 over 2 is root 3 over 4. So in total we got that the area of triangle AOB equals to 25 times root 3 over 4 square units. So we found out that the area of sector AB equals to this expression. Okay, and again we have the formula for the area of the green shape. The area of the green shape equals to the area of equilateral triangle ABC minus the area of circular segment AB. Circular segment AB. I've already presented to you this formula, that the area of the green shape equals to the area of equilateral triangle ABC minus the area of circular segment AB. We have already found out that the area of equilateral triangle ABC equals to 75 times root 3 over 4 square units. So I will write it down. The area of equilateral triangle ABC equals to 75 times root 3 over 4 square units, and the area of circular segment AB equals to this expression. So I will copy this expression. Okay, so the area of the green shape equals to the area of triangle ABC minus the area of circular segment AB. Here we will open the brackets and we will get that minus and minus is plus, so 75 times root 3 plus 25, root 3 is 100. So we will get that the area of the green shape equals to 100 root 3 over 4 minus 25 pi over 3. Here 100 over 4 is 25, so we will get the final result that the area of the green shape equals to 25 times root 3 square units minus 25 pi over 3 square units. So we found out that according to the first method, the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green shape and the area of this green shape according to first method equals to the area of quadrilateral ABCO minus the area of sector AOB. Okay, again, according to the first method, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. Okay, so that was the area of the green shape according to the first method. We actually calculated the area of quadrilateral ABCO, and then we subtracted from it the area of sector AOB, and in this way we found out the area of the green shape. Okay, so, and according to the second method, the area of the green shape, this green shape, equals to the area of the area of equilateral triangle, the big triangle, triangle CPQ, minus the area of the circle over 3. Again, the area of the green shape equals to the area of equilateral triangle, triangle CPQ, the big triangle, minus the area of the circle over 3. Because after we subtract the area of the circle from the area of triangle CPQ, we will get those 3 shapes, and those 3 shapes are identical, therefore they have the same areas. So the areas of the 3 shapes, after the area of triangle CPQ minus the area of the circle will give us the areas of those 3 shapes. So, and after we divide the area of the 3 shapes by 3, we will get the area of one shape, that is the area of the green shape. Okay, so the area of the green shape equals to the area of triangle CPQ minus the area of the circle divided by 3, according to the second method. And according to the third method, the area of the green shape equals to the area of equilateral triangle, triangle ABC, minus the area of circular segment AB minus the area of this shape. Again, the area of equilateral triangle ABC minus the area of circular segment AB equals to the area of the green shape. And how we calculated the area of circular segment AB? The area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. Okay? Again, the area of the green shape according to the third method equals to the area of triangle ABC minus the area of circular segment AB, and the area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. Okay, so we found out the area of the green shape in 3 different ways. In the first way, we the area of the green shape is the area of quadrilateral ABCO minus the area of sector AOB. In the second method, the area of the green shape equals to the area of triangle CPQ minus the area of the circle over 3. And in the third method, the area of the green shape is the area of triangle ABC minus the area of circular segment AB, and the area of circular segment AB equals to the area of segment AOB minus the area of triangle AOB. Okay, thank you very much.